Hi guys, just let me know if you guys can hear me before I start, please. All right, cool. So people saying they hear me, so that's great, right? So I really was supposed to do this a little while now, but I was a little busy, right? So I know I've been getting tons and tons of requests, right? But basically, I'm gonna be doing some exam questions today, and I'll try to do some more throughout the week as well, right? So let's have a look at some typical examination type questions here, guys, right? So as we know, question 1 in your paper is going to be based on numeracy, right? They're going to be some kind of fractions or decimal calculation or something along those lines, right? Now, in the first question, normally they would tell us using a calculator or otherwise find the exact value of, right? So you have options here, guys. You can use your calculator if you want to, right? And I would suggest that because in the paper 2, you are allowed your calculator, right? So this first question here, and by the way, this is June 2013. Most of the recent examination papers have already done all of those papers on the channel already. So I'm going further back now, right? So we have 1 and 4 over 5, right? Minus 1/3, right? Divided by 2 and 2/5, right? 2 and 2/5. Now, the trick with these questions is that you have to work out the numerator first and then perform the division, right? Let me see if I can... One second. I want to see if I can pull up my... I want you to see what I'm doing on my calculator, right? Where is this? Where is this? Right, I'm trying to pull up the calculator so you can see what I'm typing, but I'm having a little trouble here, right? So here's what I'm going to do. I'm going to use my calculator here. So basically, we're going to use 1 and 4/5, right? Minus 1/3, right? And I'm going to get 22 over 15, right? So we're going to write 22 over 15 here, right? Divided by 2 and 2/5. Now, you can leave it as 2 and 2/5, or you can write it as an improper fraction, right? That's 2 5s are 10 and 2 12, so that's 12 over 5. And then we go ahead and we divide this. So 22 over 15 divided by 12 over 5, right? And I'm going to get 11 over 18 as my answer. But like I said, my suggestion to you, because you are allowed to use the calculator in the paper 2, go ahead, right? Go ahead, because that paper 2, you're going to take a while to do the paper 2. So if you can do this quickly with the calculator, then go ahead and do it, right? So that's part 1. Part 2 here now, we have some square root and some squares, right? So I have 1.5625, finding the square root, plus 0.32 squared, right? So to do something like this, what you would do is find the square root of the 1.5625 first. So when I do that, I'm getting 1.5625, and I'm going to get 1.25 here, plus 0.32 squared, so 0.32 squared, and you're going to get 0.1024, right? So when I add this, I'm going to get 1.3524, right? So that's A part 1 and part 2. Basically, we're using our calculator to do this, right? Part B now. All right, so part B, we have what we call a best buy question, right? So Smiley orange juice is sold in two cartoons of two different sizes at the prices shown, right? So you've seen this a lot. You go to some supermarkets and they give you this deal if you buy a bigger container of something, right? And usually it's a deal, right? But whether you need that much or not is questionable. So we have 350 milliliters, right? And it's costing $4.20. We have 450 milliliters and it costs $5.13. Which cartoon size is the better buy, right? Now, the best way to work a problem like this is to work out the cost per milliliter for each of the cartoon of juice, right? So the first one, we have 350 milliliters, right, is costing us $4.20, right? So what we would do, we would find the cost per milliliter, right? So you're finding the cost for 1 milliliter. So to do that, what you're going to do, you're going to take $4.20 and you're going to divide that by 350 milliliters. So 4.2 divided by 350, you're going to get 0.012. And some students will say, so, well, when we deal with cents, we only go to 2 decimal places. But the problem is we have to be able to compare the cost per milliliter for both of them, and we need some way to differentiate between the costs, right? So in this one here, we have 450 milliliters, right? And that is costing us $5.13, right? So if we want for 1 milliliter, what we're going to do, we're going to say $5.13 divided by 450, right? And that's going to give me 5.13 divided by 450. And we're going to get, so watch what's happening here. I actually have my answer to 4 decimal places so I can make that comparison, right? So 1 milliliter, you're looking for the one that costs less, right? So you got to compare the two numbers. If you compare the bigger size, you realize this number here, right, is actually less than this number here, right? It means that for this option, the 450 milliliter option, you are actually paying less per milliliter, right? So that's your best buy. Your best buy is the 450. And that's a typical case when it comes to buying in large quantities, right? So that is part B. All right, now this one here, Faye borrowed $9,600 at 8% per annum compound interest. Calculate the interest on the loan in the first year for 1 mark, right? So this is your interest. It is 8% per annum, right? And she is borrowing $9,600, right? So the interest in the first year, so we don't need to use any fancy formulas for this, for this part at least. The interest on the loan is simply going to be 8%, right, multiplied by the 9,600, right? So in this case here, 8% is 8 over 100, right? Multiplied by 9,600, and you're going to get $768, right? So 768, that is the amount that she has to pay in interest on the loan for the first year, right? Now, in part 2, at the end of the first year, she repaid 4,368. Now, with these questions here, you have to be very careful in terms of how you reading and how you're analyzing the question, right? So she paid this amount, right? She repaid that amount in the first year. This is how much she borrowed, right? So therefore, what she's still owing, right? So what she's still owing is this. It's going to be 9,600, right? Minus the 4,368, right? And that's going to give me 9600 minus 4,368, and you're going to get 5,232, right? Now, how much is he still owing at the beginning of the second year, right? So like I said, we have to really have to analyze this to make sure we interpreting it properly, right? So in this case here, let's see what I have here. All right, so we take the so remove that amount, right? But remember, she would have had interest as well, right? Remember, you just worked out the interest that she has to pay, which is $768, right? So the amount that she is actually still owing, right? So the amount still owing, or the amount at the beginning of the second year, beginning of the second year, right? We still have to add the interest to that, right? You have to add the interest. So this is the amount she has to pay, which is 5232, right? Plus the interest, which is 768. Right? And the amount that she's going to have to pay is going to be 6,000, right? So these questions, sometimes you have to kind of analyze it properly, right? You have to analyze it properly before you could answer this, right? Right, so that's the amount that she has to pay at the beginning of the second year. That's part 2, right? And the next part, calculate the interest on the remaining balance for the second year. So the interest is simply going to be, so the interest, right? Now, because of how they worded the question, right? The question, they made it a little simpler, right? Because all we need to do to work out the interest is to find 8% of that $6,000. That's all we need to do. Right, so that is 0.08 multiplied by 6,000, right? And that's going to give me $480, right? So that's your interest that she has to pay in the second year, right? Now, I mean, you all need to remember the compound interest formula, right? And I'm sure you've seen this formula where the amount that is owed at the end of a period is given by your principal multiplied by 1 plus your rate over 100 raised to the power n. Now this here is what we typically use as our compound interest formula, right? Make sure you know that formula and make sure you also know the simple interest formula. Any one of those can come in the exam, right? All right, so that takes care of question 1, right? Question 2, right? This question 2, we have something to factorize here. The first one, all right, so this is A part 1, and you want to factorize 2x cubed minus 8x, right? Now, whenever you're not sure, right, if you have to use HCF method or difference of two squares, right? In this case here, obviously is not a difference of two squares initially, right? All you can do here is to factor out maybe 2x and start with that, right? So the HCF of 2 and 8 is 2. That's the highest number that can go into 2 and into 8, right? We have x cubed, you have x, then the highest number or the highest variable that can go into both of them is going to be x. Open brackets, so you ask yourself, 2x multiplied by what is going to give you x cubed? 2x by x squared minus, now you need to get back the 8 there, so we need to put a 4 here, and that's it, right? Now, some students, they may stop at that point there, but they're going to lose a mark, right? They're going to stop there and they're going to lose a mark. And here's why, right? Because you see, whenever you see CSEC tells us to factorize completely, it's usually a hint in the question, right? It means that there may be a trick inside here that you may need to pay attention to. If you all look carefully, x squared minus 4 is actually the difference of two squares, right? So that can further, you can further factorize that. So in this case here, we can write this as 2x, open brackets, x plus 2, x minus 2. So some of you all might be wondering, where did he get that from, right? When you factorize any difference of two squares, right, it is equal to a plus b in one bracket, a minus b in the second bracket, right? That's what we call the difference of two squares. So if I have x squared minus 4, right, that's the same as saying x squared minus 2 squared. So therefore, this is going to be x plus 2, x minus 2, right? That's what's happening here. The next one that we have to factorize is 3x squared minus 5x minus 2. Now, there are various methods that students use in order to factorize a quadratic. And what I suggest you do is you go ahead and use whatever method you are comfortable with, right? So normally in my online classes, I teach a longer process where we look at the sum and the product, and from there we can factorize this by grouping, right? Now it's a little longer, right? But it's a foolproof method in order to factorize these things. But you can also use trial and error in order to factorize. So there's some students who can look at this and they can write the answer in one line and they will get full marks for it. So if you have 3x squared minus 5x minus 2 and you want to factorize that, you know it's a quadratic, so we're going to get two brackets, right? If we look at this first term here, we just have 3x squared. So the only way you can get 3x squared is by having a 3x and an x here, right? We look at the last number here. You have minus 2. Now there are various ways we can get minus 2. If I put a 1 here and I put a 2 here, right, you'll get 1 by 2, which is 2. But you have to get minus 2, right? But at the same time, you need to get a middle term of minus 5. So the only way you can really do that is by putting a minus here and a plus here, right? And that's it. That's your answer for 2 marks, right? You have 3x plus 1 in one bracket, x minus 2 in the second bracket, right? Let's need some blank sheets here. All right, now the next part, part B, part 1, we have a question based on changing the subjective formula, right? So this is a conversion between Fahrenheit and degrees Celsius. We have F is equal to 9 over 5 C plus 32. Right? So that is what my equation is, conversion from degrees Celsius to Fahrenheit. Now we want to make C the subjective formula. Now, whenever you have a question like this, you need to understand what are they really asking us to do. So they want you to take that equation. Right now the equation says F is equal to something. They want you to rearrange the equation so that you get C is equal to something, right? Now, this is a trick that I normally teach my students in class, right? Instead of trying to bring the C onto the left-hand side, this is what you should do. If your left-hand side of the equation is equal to your right-hand side, it means that the right-hand side must also be equal to the left-hand side. So I can do this. I can say that 9 over 5 C plus 32 is equal to F. And then some students might look at me and say, sir, why you didn't change any signs, right? It has to do with the fact that if the left-hand side is equal to the right-hand side, then the right-hand side must equal to the left-hand side, right? It's straightforward logic, right? And it works. So let's see. So next thing, we want to make sure we only have C on the left-hand side. So what I would do, right? I would say here what? 9 over 5 C, right? Now I'm going to move the 32. So the 32, I'm going to put it to the right-hand side. So this becomes F minus 32. Next thing you're going to do now, you're going to say, well, how are we going to get rid of that 9 over 5? Well, there's an easy way to do that. All we need to do is to multiply both sides of the equation by 5 over 9. And some people might say, well, why are we doing that? If I take 9 over 5 and I multiply by 5 over 9, it means that this will cancel with this will cancel with this, and I will get 1. So therefore, I will end up with only C on the left-hand side. So therefore, C is equal to, now since you're multiplying by 5 over 9 on the right-hand side, you need to write it like this. 5 over 9 multiplied by everything on the right-hand side. So it's F minus 32 in brackets, right? So that is what C is going to be equal to. Right, I just now getting a chance to watch your chat here. Right, so everybody begging for AdMats. Right, I'll see if I have some time. Maybe I'll do something the night before. I'll see. Right, I see somebody said in Form 3 they're gonna write maths. Right, excellent. Yeah, I'll see what I can do for add months. I'll see, right? Might be able to do a little something. Right? Somebody's saying about 5/9 divided by. Remember what I'm doing here, right? All I'm doing here is multiplying both sides of I'm multiplying both sides of the equation by 5/9. That's what I'm doing. Or you can think of it as f minus 32 divided by 9/5. However way you think of it, that's fine. Right, so let's see what's the next part to the question here, guys. All right, so this one here, 500 tickets were sold at a concert. Of these, X tickets were sold at $6, and the remainder was sold at $10 each, right? Now, lots of students, they get confused when they read questions like these, right? So we have 500 tickets, so the amount of tickets that is selling here is 500, right? That's the total number of tickets. Now, of the tickets, X of them was sold at $6 and the remainder is sold at $10. Write an expression in terms of X for the number of tickets sold at $10 each, right? Now, in terms of tickets, right? So they would have had X tickets and they would have sold those for $6 each, right? Now the remaining tickets, remember this here is the total number of tickets that they would have sold, 500. So if you sold X of them at $6, it means that what you have left is going to be 500 minus X, right? So don't get confused by all the X's. I know students, they dread those things, but try not to get confused by that, right? You had 500 tickets you sold in total. If you tell me you sold X of them, the remaining amount will be 500 minus X. And we're selling this here now for $10, right? That's what they say, $10. So let's see. So they want to know, write an expression in terms of X for the number of tickets sold at $10. So this answer here is going to be 500 minus X. 1 mark for that because they consider that to be pretty easy, right? Part B now, the total amount of money collected for the sale of the 500 tickets, right? Now, if you selling, right, X ticket for $6, the total amount of money you will collect will be 6X, right? That's how much you're going to collect. And if the remaining tickets are sold for $10, then that means that the price that you're going to pay is going to be 10 multiplied by 500 minus X, right? That's the amount of money that you're going to collect from the remaining tickets. But here's the problem. The question asks us for the total. So the total is going to be the 6X plus the 10 by 500 minus X. Now the thing is, you could decide to leave your answer like that if you want, because if you notice it's only 1 mark, or you could go ahead and simplify it if you want. So this is going to be 6X plus, when you remove any brackets, it's going to be 10 by this, so that's 5,000, right? Then I have to take this 10 and multiply by minus X, so this is minus 10X, right? So this is going to be 5,000 minus 6 minus 10 is going to give me minus 4, right? That's going to be my answer here. All right. So that is part 1A and B, right? And the last part here now, they said the sum of $4,108 was collected for the sale of the 500 tickets. Calculate the number of tickets sold at $6. Now, I don't know why they're giving you 3 marks for this, because that is very straightforward. All we're going to do, right, this is the total amount of tickets sold, 5,000 minus 4X, and the money that they collected here was 4,108. Now, remember, X tickets were sold at $6. So all they're really trying to ask us in SMART here is to solve this equation, right? So what I would do, I would say minus 4X is equal to, you carry the 5,000 on the right-hand side. So 4,108 minus 5,000 right? So minus 4x is equal to 4108 minus 5123. So this is going to give me 892. So, sorry, minus 892. So therefore x is minus 892 over minus 4. And I'm going to get 223 tickets. So that's the answer for this one here, right? Because X represents, they told you here, X tickets were sold at $6. So we're solving for X, right? Alright, Anime G21, yes, I do know Keaton, yes. He is in my class. Right, I've seen a lot of people asking about AdMats here, right? So we'll see. Once I have a little time, we'll see what I can do. Just now, just going back to a question here. I feel I left out a piece. Yeah, I did. Right, I left out a piece here. Part 2, right? I realized they said F is 113. I didn't work out C, right? Let me just work that out quickly. So F is 113, and they want to work out C. Well, that is easy because we just worked out what C is. So this is going to be 5 over 9 multiplied by 113 minus 32. So that's going to be 45, right? So that's 45 degrees Celsius. All right, so that is question 2 in this particular paper, right? All right, we have a question here pertaining to, we have 2 points, A and B, right? So this is what I normally tell my students to do. As soon as they give us points and they're talking about a line segment, right? What I would do, I would label my points properly first. So -1, 4. B is 3, 2, right? And what I will do before I do anything in the question, right? I'm going to call this x1 and I'm going to call this y1. I'm going to call this x2 and I'm going to call this y2, right? So once I label those things here, it's going to be very easy to use the formula in order to determine my gradient. So check this. So part 1, you want the gradient of AB, right? So the gradient has a formula, which is y2 minus y1 over x2 minus x1. Now guys, you have to learn this formula. It is not given to you in the exam, and I can guarantee you in the question, you are going to get a question pertaining to this. Every year they bring a question on this, right? Right, so I'm just going to substitute because I know what I'm going to plug into the formula. So it's going to be 2 minus 4, right, all over 3 minus 1, right? Now, normally when I'm doing questions, I try not to leave out steps, right? So 2 minus 4 is going to give you -2. Now, 3 minus 1 is the same as saying 3 plus 1, so this is 4. So this is going to work out to give me -0.5, right? So that's your gradient, or that's your answer for this part here for 2 marks, right? The second part, they want you to work out the coordinates of the midpoint of AB, right? So let's say this is A. Let's say this is B. Now this is just for visualization purposes only. So this here is your midpoint that you're trying to find here. So there's a formula for midpoint that is not given to you in the exam, but you need to know it. So midpoint is given by this formula here. x1 plus x2 all over 2. y1 plus y2 all over 2. Right? So you're going to add the two x values. So -1 plus 3 over 2, right? Y1 plus y2, so this is 4 plus 2 over 2. So minus 1 plus 3 is going to give me positive 2 over 2. This one is going to be 6 over 2. So therefore your midpoint is going to be 1 and 3, right? So 2 marks for calculating what that midpoint is, right? Right, I hope you all not too lost. I mean, you all have exams literally next week, right? All right, so while you guys here, just remember to hit like and subscribe for me, please. Right. All right, now we want to find your equation of your perpendicular bisector. That's what we want, right? You want to get equation of the perpendicular bisector. Now, here's what a perpendicular bisector is. So if I have a line segment E, so this is A here, and let's say this is B, right? Now, your perpendicular bisector, right, actually passes through the midpoint of your line. So this dashed line that I'm drawing here is what we call our perpendicular bisector. So this here is your perpendicular bisector, right? That's your perpendicular bisector. Now, when we say perpendicular, it means that that line is cutting AB at 90 degrees. So this angle here is 90 degrees and it's passing through the midpoint. So that's why they asked us to work out the midpoint. So the midpoint that we got just now was 1, 3, right? Now the gradient of AB, they made us work out that. So the gradient of AB right, we got, I think it was -1/2. Let's double check that. Yeah, we got -1/2, right? So this here is -1/2, right? Now the gradient of the perpendicular bisector now, right? So that perpendicular line there. So one of the rules or one of the geometric properties that we need to know is that when you multiply the gradient of two lines which are perpendicular, you should get -1. So you have to ask yourself, this multiplied by what will give me -1? So what I normally tell students, you invert and you put a minus sign in front. So if you invert a half, you're going to get 2. And if you put a minus sign in front of it, you're simply going to get 2, right? So what we're saying is that if I take -1/2 and I multiply by 2, right? This 2 will cancel with this and you'll get -1. This here is a property of lines which are perpendicular. So what I just did there, I worked out the gradient of the perpendicular bisector without doing anything really, right? So this is what we know. So the equation of the perpendicular bisector is going to be y is equal to 2x plus c, right? Y is equal to 2x plus c, because we just worked out that the gradient of the perpendicular bisector is 2. Now we need to figure out what c is, right? Now to figure out what c is, we're going to use your midpoint in order to do that. So the midpoint is 1, 3. So when x is equal to 1, y is equal to 3, So I'm going to substitute those two things into my formula here. So 3 is equal to 2 by 1 plus c. So 3 is equal to 2 plus c. So I can say 2 plus c is equal to 3. C is equal to 3 minus 2, which is 1. Right? So the equation of the perpendicular bisector, right, is going to be y is equal to 2x plus 1. Right? That's the equation of the perpendicular bisector. Right, somebody's asking to do half the question. It depends on the amount of working that you guys it depends on what you how much working you actually put and what makes sense to the examiner or not, right? Right, let's see. So what we have to do again here. So, right, so this is our next question here, right? I only selected the questions that are pertinent to, that we could actually do here, right? I think this is question, what question is this? So it's question 5, right? An incomplete table shows one pair of values, right, of A and R, and A is directly proportional to the square of R. So this can come in your exam. It's proportionality. So in part 1, we have A. We want to express A in terms of R and a constant. Now, you have to read this carefully, right? A is directly proportional to the square of R. So you write A is proportional to the square of R. Now, the square of R is simply R squared. Right? So that is my relationship between A and R squared. But the thing is, some students may write that alone, but if you notice, they want you to write it in terms of a constant K. So anytime you want to remove a proportional sign, you have to include a constant. So therefore, A is equal to K times R squared. Right? A is equal to K times R squared. Right? So that's the answer that they want. Don't just put this. You need to put this in order to get the mark. Right? So that's part 1. For part 2 now, we want, so this part 2 here, calculate the value of the constant. Now normally, if they give us data in a table like this, what we have to do, we have to find a value of, for each one of them in order to find K. Now, since we know that A is equal to K times R squared, that's the formula. You know that A is 36. So this here is 36 is equal to K multiplied by R squared. So this is going to be 3 squared. So therefore 36 is equal to 3 squared is 9. So this is 9K. So therefore I can say that K is 36 over 9. So this is 4. Right? So once you know what K is, you know exactly what the formula is. So the formula is A is equal to 4R squared. That's your formula, right? And once I have that formula, I could work out anything in the table that I want. So they said copy and complete the table. So you're missing this piece here, but you know that R is 5, right? So R is equal to 5, and you want to find what A is. The formula is 4R squared. So therefore it's going to be 4 multiplied by R squared, which is 5 squared. So 5 squared is 25. 25 by 4 is 100. So this is just 100 here, right? And what do we need here again? We need to figure this out here. So in this case here now, A is equal to 196. So you want to figure out what is R. So we're going to put K, sorry. You know what k is already. We can write 4r squared is equal to 196. So r squared is 196 over 4, right? So r squared is going to be equal to 49. So r is the square root of 49. So r is equal to 7. So 7 is going to come here. Right, guys? So maths is all about a mindset. So if you think the exam is going to be hard, it is going to be hard for you, right? Or it's all about a mindset and all about being confident as best as you can, right? I'm sure the paper is going to be okay. It's going to be fine, right? Right, so that is part E, right? Let's see what else we have here. Right, so this one here is based on functions, right? We have two functions here, f and g. So f of x is equal to 2x plus 1 over 3. And we have g of x is equal to 4x plus 5, right? And what do we want? We want to find, in part 1, you want to find fg of 2. So fg of 2, that's what we call a composite function, guys, right? Now, to work out a composite function, what we do, we read from the right-hand side. So we need to find g of 2, and the answer we get, we're going to plug that into f. That's what we're going to do, right? So g of 2, so g of 2 is equal to 2 multiplied by 2 plus 1 all over, plugging it into the wrong formula, right? G of 2 is, we're using this here, right? We're using this one here. So this is 4 by 2 plus 5. So that's 4 2s are 8 plus 5. So that's going to give me 13, right? Now that answer that we get there now, we're going to plug that into the function f, right? So we're going to find f of 13 now. That's what you're going to do. So you're going to plug that into this function now. So that's going to be 2 multiplied by 13 plus 1 all over 3. So 13 by 2 is 26 plus 1 all over 3. 26 plus 1 is 27. 27 over 3, you're going to get 9, right? So you could just tell them, here what? Fg of 2 is simply equal to 9, right? It's a two-step process that we have to use in order to work this out, right? All right, so let's see what we have again, right? So that's part 1. That's a composite function. The next one here is part 2, and we have to find f inverse of 3, right? F inverse of 3. So go on the next page to do this one. F of x is equal to 2x plus 1 divided by 3. Right? And what we are asked to find is f inverse of 3. Right? We are asked to find f inverse of 3. So what we're going to do, right? This again is a two-step process. What we need to do first, we need to figure out what is the inverse function, right? And finding the inverse function, there's a process that we follow. So let me give you the steps. Step 1, you're going to say let y equal to 2x plus 1 all over 3. That's step 1 in your process. Let y equal to that, right? Once we let y equal to that, the next step in the process is to interchange, right? So we're going to interchange x and y, right? Now what does that mean? That means that anywhere you see x, you're going to put y, and anywhere you see y, you're going to put x. So we're going to say x is equal to 2y plus 1 all over 3, right? Now here's the problem. Some students, they reach this far and then they can't make y the subject of the formula, because that's the next step, right? So what I normally tell my students online, right, is here what? Write that x as x over 1. And things become much clearer when you write it like that. So what you can do, you can cross multiply. This by this is equal to this by this. So this becomes 2y plus 1 is equal to x by 3, which is 3x. So 2y is equal to 3x minus 1. So the last step here now is this. Y is equal to 3x minus 1 all over 2. So therefore, your inverse function is simply going to be 3x minus 1 all over 2. That's your inverse function, right? Now the question asks me to work out f inverse of 3. So therefore, all we do is we substitute in 3 into this formula here. So this is going to be 3 by 3 minus 1 all over 2. 3 3s are 9 minus 1 over 2. This is 8 over 2. So this is 4. Right? So f inverse of 3 is going to be 4. Right, so let me do question 6 for you all here. I just need to pull the question. All right, now, so this is question 6, right? And like I said, it's June 2030, right? Now, a car is traveling along a straight road at constant speed of 54 kilometers per hour. It takes 20 seconds to travel the distance between two signposts. Calculate the speed of the car in meters per second. Now, this is a good question here, right? Because there are some students who they have difficulty dealing with kilometers per hour and meters per second, right? I, for one, first time I saw this in secondary school, I really wasn't sure how to work this out, right? But I do now, right? So all we need to do here, you know that the speed of the car, so this is what we know. Speed of the car is given by 54 kilometers per hour, right? Now let me write it exactly like how CSEC has it in this question, right? You have it like this. Now what that means is that you are traveling 54 kilometers in 1 hour, right? That's what that means, right? So if you want to convert this, let me do it on the side because I might need some space. So the first thing we need to do, you're converting to meters per second. So 54 kilometers, if you want to convert that to meters, you multiply by 1,000. So this here is going to be 54123 all over 1 hour. Now remember your one, so this here is in meters. So we need to have our time at the bottom here in seconds. So 1 hour is actually 60 minutes. And if we multiply that by an next 60, we're going to get 60 seconds, right? So all I'm doing is converting the kilometers into meters, and I'm converting the hour into seconds, right? So this is going to be 54,000 all over 60 by 60. That's 3,600. And this here will give me my answer in meters per second. So that's 54,000 divided by 3,600. And I'm going to get 15 meters per second, right? So this is a conversion that you really should know how to work out, right? right? I saw some of you asking for maths crash course, right? Essentially, it would have been based on past papers anyway, right? So I'm gonna give you whatever scraps of time that I do have, right? Because I'm pretty busy these days. Right? So the answer is 15, right? So that is the answer for part 1. For part 2 now, they want you to work out the distance in meters between the two signposts. So you all need to know for the exam that speed is distance over time, right? So if you want to work out distance, distance is simply speed multiplied by time. So your distance between the signposts will be distance is equal to s multiplied by t. Now, since I want to answer in meters, I have to use meters per second in order to do that. So your speed is 15 and your time, they told you the time. Time is in seconds, 20. So that's 20. So that's going to be 15 by 2, that's 30. So it's 300 meters as the distance between the two signposts, right? So again, that is kind of straightforward. This next one here is part B of this question is based on transformations. All right, so let's see what they want here, right? Let's see what they want. Alright, so while I'm copying the questions here, right, don't forget to hit like and subscribe and share the YouTube channel for all those people who want quality help here, guys, right? Alright, so here what we have here. So we have the graph below shows triangle LMN and its image L prime, M prime, N prime after undergoing a single transformation, right? So part 1 of the question says to describe the transformation as that maps LMN to L prime, M prime, N prime. So there are 4 different transformations that you guys have to know for the exam, and that is translation. You have reflection, right? You have rotation, and you have enlargements, right? What CSEC has been doing is that they have been incorporating all these 4 transformations in one exam question, right? That's what they've been doing in the past few years, right? One exam question that includes the 4 different transformations, right? So in this particular case here, right? If you look at the diagram, you can say, well, it's not a translation. It's not a translation because the orientation of the triangle seems to be different, right? It is not an enlargement because the size of the 2 triangles, they're the same. So there's no enlargement taking place here, right? But if you look carefully, it looks like a reflection, right? Now, a reflection, right? So it's a reflection, but you guys have to say more than just a reflection, eh? You have to say a reflection in the line. So in order to get the marks here, right, you have to indicate what is the mirror line, right? Now your mirror line is simply the line such that if I fold the paper along the mirror line, the object and the image, they're going to line up exactly. So you have to visualize the paper folding along a line. So if you look carefully, it is actually going to fold, if I fold it along this line here, right? If I fold it along this line here, the 2 triangles are going to line up exactly. But you have to look and see where is that happening. That is actually happening at x is equal to 7. So if you want to get full marks for this, you need to say reflection, yes, but you also have to indicate what is that mirror line. And the mirror line in this case is x is equal to 7, right? Right, so that is part 1, right? On the answer sheet, now the thing is, I don't have the answer sheet, so I'm hoping I could fit it on this diagram. Let me see. 0 minus 3. Okay, yeah, I should be able to fit it, right? So they said on the answer sheet provided, right, they want us to draw L double prime, M double prime, N double prime, which is the image of LMN after translation of 0 minus 3. Now, whenever you are given a translation in the form of a vector, right, in this case is 0 minus 3, the top number here tells us our movement in the x direction, right? That tells us our movement in the x direction, right? So that's your horizontal movement. The number at the bottom tells you the movement in the y direction, right? So in this case here, right, in this case here, your x direction, they're telling us that we're not moving in the x direction at all. However, you are moving in the y direction. But because it's a negative sign, you have to be moving downwards. So let's go to the diagram LMN. So the vector is 0 minus 3, right? LMN is this here. This, right? Now, you can start with any one of the points that you want, right? So let's say if we start with L. You're not moving in the horizontal direction, but you are moving downwards by 3 units. So you're going to go 1, 2, 3 units. So therefore, L double prime is going to be here, L double prime, right? We're going to do the same thing for the point N. No movement in the x direction, but you're moving 3 units downwards. 1, 2, 3. So this here represents our N double prime. And the same thing for M. M is not moving in the horizontal direction, but it's moving down. 1, 2, 3. So we're here, right? So in this case here, right? Right? That represents our image, right? After it undergoes this transformation, right? Right, so let's see what else they want here in this question. Okay, the third part. They said name and describe a combination of 2 transformations which may be used to map. So here's what we're trying to do. We're trying to map this onto this here, right? So let's go back and see where we're trying to go to. So you want to map this triangle here onto this triangle here, right? And what they're telling me to do here is to undergo 2, so what they're saying here? They said name and describe 2 transformations which may be used to map, right? So here's what I would do, right? Now you could do it in a reverse order if you want. You can perform the same transformation, start off with this triangle here, shift it upwards, and then reflect it in the line x is equal to 7. You could do that if you want, right? That's an option. Is there another option? We can also reflect it first and then shift it upwards, right? Let me make sure it's from, it's from the double primes to the primes, right? So let me see if I can explain this better, right? So they want to know, how do I take this and how do I bring it across here, right? So there are different possibilities that I can do. First thing you could do, you could shift it upwards and then reflect it in this line and you'll get it, That's one way we can do it, right? The other way that we can do it here, right, is to first reflect it here, right, and then shift upwards. So you have options. You have more than one answer for this particular part, right? So either you reflect and then you translate, or you translate and then reflect, right? So let's see what other questions we have here. Right, so this question 7 here, right? This is question 7 here. They tend to they kind of love cumulative frequency, but I have my doubts that that one is coming in your exam. I have my doubts, right? Right, and even if they bring a cumulative frequency, the kind of the way that they ask the questions now, it's very different to how it would have been asked in the past, right? It requires a little more thinking, right? So here's what's happening here. The table below shows the amount to the nearest dollar spent by a group of 40 students at a school canteen during a period of 1 week, right? During a period of 1 week. So we have number of students, so that's like our frequency, right? That's number of students. And what they have here, they have cumulative frequency, and they want us to complete this table here. Now, when we're working out cumulative frequency, it's as if we keep adding up our frequencies. So up to this point, our total cumulative frequency is 3. When you reach this here, this interval here, you have to add 7 plus 3, that's how you get 10. When you reach here, you're going to have to add 7 plus 3 plus 9, that's how they got 19, right? So every time you add a new row, all you need to do is to take this number and add the new frequency. So in this case, it's going to be 19 plus 11, right? So that's going to give me 30, right? Then to get the next cumulative frequency, I have to take this 30 here and I have to add 8 to it. So this is going to be 38, right? Then to get this one here, I'm going to take the 38 and add it to this 2. So you're going to get 40, right? So that represents my cumulative frequency table, right? Now the next part of the question, right, that's part B. Right. They said using a scale of 1 cm to represent 5 units on the horizontal axis and 1 cm to represent 5 students on the vertical axis, draw a cumulative frequency graph for the data, right? And if you notice what they said here, marks will be awarded for axes appropriately labeled and points correctly plotted, right? And a smooth curve carefully drawn, right? Now this is a lot of marks they're given here for this particular part of the question, right? We have to draw a cumulative frequency curve, right? Now, before you draw any graph, you should conceptualize or try to understand exactly what am I drawing, right? So you're plotting in this case here. So we know here has to be cumulative frequency, right? That's cumulative frequency, and your amount of money spent has to be here. So amount spent in dollars right? It has to be here, right? Now, just look at the numbers. We're going from 1 to 10, and we're going to write right up to 60, right? So this is 0 here. Now, I just want to get my bearing in terms of what they said. On your horizontal axis, 1 cm to represent 5, right? So that means that when you drawing this here, you're going to be going 5, 10, 15, and we go right up until we reach 60, right? That's your cumulative frequency. You're going to do the same thing on the vertical axis as well, because it said 1 cm represents 5 students. So therefore, in terms of students, this will be 5, this will be 10, this will be 15, 20, and we keep going, right? Now, in terms of how the graph is going to look, it's a cumulative frequency curve. So the curve is going to look like this, right? It's going to look something like that. Now, please, when you're drawing this, you're drawing a smooth curve. We're not joining the points together, right? You're not joining the points together. And when you're plotting your points, you have to remember, what am I actually plotting, right? Now, to begin with, we are plotting cumulative frequency. I've seen students plot amount of money against students, right? You have to plot cumulative frequency. That's what we're using, right? And here's what you have to remember as well. When you're plotting your cumulative frequency, we use what we call our upper class boundary, right? You have to use your upper class boundary when you are plotting cumulative frequency. So for each class interval, you need to use the correct upper class boundary. So this here, right? So you have 10 here and we have 11 here. So your upper class boundary for this interval is 10.5. This one is 20.5. This one is 30.5, 40.5, 50.5, and then the last one is 60.5. So what you're plotting is upper class boundary, so that's UCB, against cumulative frequency. You all have to remember that, right? Don't mix up that in the exam, because sometimes we have they might ask us to plot a frequency polygon. If it's a frequency polygon, then we have to use midpoint. If we're using or if you have to plot a histogram, we have to use lower class boundary and upper class boundary, right? So these are things that we have to pay attention to when we plot in these graphs, right? All right, let me see if I can get, give me a sec there. I want to pull up a graph paper. Right, just give me a sec here. I just want to get let me get a graph paper here so we could use. All right, hold on. Right, just hold on a second. I'm just trying to get a sheet of graph paper here that I could use. Right, hopefully I get one soon. All right, so let's use this as my graph paper here, right? All right, so what I'm gonna need the data. All right, so this is the data that we're using to plot the graph, right? We already know the scale that we're using, right? So let me get some all right, so here's what's happening here. So we have on this side here, make sure you all seeing what I'm doing, yes? All right, so on your vertical axis, you have cumulative frequency. You need to label that, right? Cumulative frequency, right? Next thing now, we're gonna have on the horizontal axis, this here is amount spent in dollars, right? That's what we're gonna put here, amount spent in dollars, right? So this is 0. Now they told us what scale to use, right? On the horizontal, we're using 1 cm to 5. Same thing for the y-axis, 1 cm for 5, right? Now somehow I find that that graph might be looking a little small still, eh? Now the amount of money spent, the largest number we have here is 60. So we're only going up to 60. So this is 5, 10, 15. Okay, so kind of small there, right? So let me, because I don't want to clutter the diagram, I'm going to put 10, 20, 30, 40, 50, 60, right? So that's the amount spent there. We're going up to 60. On the cumulative frequency side, the highest we're going up to is 40. So again, 10, 20, 30, 40, right? So this is a very small graph because we're only going up to 40, right? So the first point that I'm going to plot here is 10.5 against your cumulative frequency of 3. So 10.5 against, so that's 11, 10.5 against 3, so that's somewhere here, right? So you try to plot as accurate as you can. Second point you're plotting is 20.5 against 10. So 20.5 against 10 is going to be here, right? Now when you are plotting your points, you have to use a small x, or you can use a dot with a small circle around it, right? But I don't want to clutter my diagram, so I'm just going to use a dot. This one here is 30.5 against 19. So 30.5 against 19 is here. Then we have 40.5 against 30. So 40.5 against 30 is somewhere here. Then we have 50.5 against 38. So 50.5 against 38 is somewhere here. Right? Now it's looking like a straight line, but it's not really a straight line. 60.5 against 40. 60.5 against 40 is somewhere here, right? So what you have to do now, you have to draw a smooth curve through these points, right? Now what we normally do, we will assume that there's an interval before this, so we can have our cumulative frequency at 0. So I'm going to plot a point here, right, to make that happen. So next thing you're going to do now, you're going to try your best, right? And I'm going to try my best here, right? It's hard to draw on a digital screen, right, when compared to a piece of paper, right? So let me see. So I'm going to try my best here to draw a smooth curve, right? So not too bad actually, right? So that's my curve here. That's my cumulative frequency curve, right? And that there is for 5 marks for drawing this, right? So you're selecting the best possible points that we can use in order to do that, right? The next part of the question, what's the next part of the question? Let me see. Right, next part is, right, they want us to use a graph to estimate certain things, right? So for that, right, so what they're saying here now, use your graph to estimate the median amount of money spent, right? Now, here's what you have to do to find median. So the graph looks like this, right? So let's say this is the highest value that we have, right? Let's call that n. To get the median, what we need to do, we need to read off half of that value from the graph, and we need to come down here, right? This point here is going to be your median, right? That's what they want me to estimate. So you're going to go to the graph, all right? You have to look at what the highest cumulative frequency is, which is 40. So you have to find half of 40, and then you're going to read off that from the graph, right? So here's what you're going to do. In this case here, we'll have to draw straight lines in real exam, eh? So I'm going to read off at 40. Actually, wait, let me just use our next line here, right? So again, you're going to read off at 40. Right? Read off at 40 here, right? And then you're going to come down with that graph. Right? Some people think the answer is 40, right? Sorry, the answer is 20, right? Please don't do that. Once you find half of it, the next thing we need to do is to actually read it off from the graph, right? So according to my graph here, and this value is going to be an approximate value, because it depends on how you draw your graph. So you might get a different answer to your partner in class, right? In my case, it looks like I'm getting maybe about 31 as my value, right? I'm getting about 31, right? So like I said, it depends on what you read off for your answer. So I'm getting about $31, right? So my median is this value here, right? Which is about $31, right? So the median is about $31, right? That value is going to vary depending on the student, right? The second one here, what's the probability that the student chosen at random spend less than $23? Now, one thing you have to remember when it comes to a cumulative frequency graph, it always gives me less than, right? The graph always gives you less than. So whenever you see a question asking about more than, right, you have to do something a little different. So they said less than $23, right? So first things first, let me clean up this diagram a little bit. Right. So we want $23, right? So what you're going to do, you're going to go to the graph and you need to read off where is $23, right? So $23 is 21, 22, 23 is about here, right? So you're going up to the curve, right? And you're going across, right? So you're going up to the curve, but you're going across it. Right? Now, like I said, it's going to vary depending on how you draw your graph, right? I want you to understand the process. Right? So to me, it looks like maybe 10, 11, maybe 12 students, right? That's what I get, and probably about 12 students. Right? So according to my graph, I am getting a value of around 12 students, right? So let's see what the question asks though. Oh, they want probability, right? So the number of students spending less than $23, right? So from the graph, we got 12 students, right? So the probability that they're looking for, all we need to do is to take the 12 students and we divide it by how many students you have in total, which is 40, right? So the answer is 12 over 40, or you can reduce that if you want, and that's going to give you a probability of 3 over 10, right? So if you notice, they said in the question, use broken lines to show how the estimates were determined. Well, I didn't use broken lines, but you need to draw lines on a diagram in order to measure these things, right? You need to do that. Right, I'm just gonna do one more question with you guys, and that is question 8, right? Because that's all the time I have right now. So question 8 is based on pattern question. Right, so for sure, question 7 in your exam is going to be based on pattern, right? All right, so what do we have here? We have the drawings below show the first 3 diagrams in a sequence. So basically we're looking at maybe cuboids or cubes here. Can't tell as yet unless they tell us something. Each diagram is made up of wires of equal length. Okay, so equal length, so everything is a cube, which are joined at the ends by balls of plasticine. Diagram 1 is made from 12 wires, 8 balls. Each new diagram in the sequence is formed by fitting a frame as shown on the diagram, right? Diagram 2 has 8 more wires and 4 more balls than diagram 1. On the answer sheet provided, draw a sketch to show, right, diagram 4. Well, all you guys need to do here to draw diagram 4, right? We just adding on a piece here. So I'm not going to draw this diagram. I'm just going to... So all you're going to do, right? So this here, this would have been your diagram tree, right? And all we need to do is to just do this, right? So to make diagram tree, I'm just going to complete this here, right? So this here would be diagram 4, sorry. Right? I'm not going to draw it over, but that's all we do. We just add in a piece to the diagram. So that's diagram 4. Right? They said draw a sketch of diagram 4. That's what they're looking for. Now the next part of the question here has to do with the table, right? So I literally just did a review of this, not this question, but a review of this topic with my Form 5 maths class, right? All right, so let's see what's going on here. Complete the table by inserting the missing values, right? And we want to write the rules for W and B, right? Now, when you have these questions here, you're trying to find some kind of pattern that is somewhere there, right? Now, in this case here, we have 12 and we go into 20, right? So all you're doing here, you are adding 8 to this. When I jump from 20 to 28, again, I'm adding 8, right? Now, what you should really do when you have to work a problem like this, you need to find a general formula that's going to help you, right? So if you notice the number of wires, that 8 appears, it appears more than once, right? So 8 is going to appear in my formula. So it's going to be 8n. Now we need to find out, well, 8n plus or minus what? If I put 8n plus 4, this is going to work out nicely for us. We need to test it with these 3 values of n in our formula, right? And if you test it, it's going to work out, right? If I check the number of balls, when I go from 8 to 12, I'm adding 4. When I jump from 12 to 16, I'm adding 4 again. So again, for this formula, it's going to be 4n, and let's see, 4n plus 4. yeah, 4n plus 4 is going to work out nicely for us, right? So once you have the general formula, it's very easy to work out these things here. So for this one here, for this rule, this is going to be 8 by 4 plus 4. So that's 8 4s are 32. 32 plus 4, this is going to be 36, right? For the next one, we're going to use the formula 4n plus 4. So that's 4 4s are 16 plus 4, which is going to give me 20. So this is 4 by 4 plus 4, that's 20, right? So we're using the general formulas that we just came up with, right? And then for 20 now, that's this rule, you're going to plug 20 into your formulas. So that's 8 by 20 plus 4. So that is 8 that's 160 plus 4. So this is 164. And then the next one will be 4 by 20 plus 4. That's 4 2s, that's 80 plus 4. This is 84, right? So this is easy marks in the exam here, right? Easy marks because we worked out a general formula. And in part C now, they asked us write the rules based on the values W and B. Well, we already worked out the rules, right? So our thing is going to be 8n plus 4. And for the number of balls, it'll be 4n plus 4. So this was an easy sequence question, right? Easy sequence question. Alright guys, so that's it for me for tonight, right? Like I said, if I get a chance tomorrow, right, I will probably I'll probably do a live stream tomorrow if I can, right? So guys, good luck with your studies, right? Just make sure you hit like and subscribe, share the YouTube channel, that's fine, right? It's meant to help students in the Caribbean, right? That's what it's meant for, right? I started doing these things 10 years ago, right? 2023 makes it 10 years since I've been doing this, right? So guys, I'll see you guys tomorrow, hopefully, right? So enjoy the rest of your night, guys. Be safe. Take it easy, everybody. I'll probably be after 8 as usual, right? After 8.